Hey guys, how's it going? So this is the next stream, and hopefully you guys are all doing all right. How's it going, Lion Cat and Lane Gores? Good to see you guys. So I got some music playing, which is something my brother recommended. Let me know if it's too loud. I might turn it down a little bit for myself. But yep. So today we are going to be upgrading OpenGL and stuff. CGO clan, bugs, vertical font metric support. Yep. Block textures disappear. You'll have to let me know about that one. White line above my head. Oh, yep. I think Mr. Hacker pointed that one out. And physics teleportation bug. Yeah, I got to work on that one. And then white lines between blocks. Gotta check that out too. And Eddie Dev, how's it going, man? I hope you guys are all doing all right. So we'll be taking a look at some of those bugs. One thing I really want to work on today, though, is OpenGL, upgrading to 4.6 and taking advantage of some of those things. And we'll talk about all that in a little bit as well. And hey, CGO clan, yep, how's it going? So if we take a look, first of all, I should mention I've made a lot of changes since last week because I've been working quite hard to change just sort of the format. So yeah, you can see that this white line is below. That's fine. I just needed like a text input box for now, so I just coded something up real quick that would work. And then if we just code that in there, or just put something in there, we get a new world generated. And I have added support so you can add and break blocks. So that's great, right? We've got like pretty good support for this. And I'll go over how I accomplished all this in just a second too. There are some problems with this too though, because like if we go a little bit further in, and I can't go under 2 block high things. Okay, yep, there we go. So basically if we hit a chunk boundary, I'm not updating all the appropriate chunks yet, but once you update that, it'll fix whatever errors there are. So that is another thing that I've got to fix today. And speaking of that, that'll be like a pretty easy thing that we can start off with fixing, and we can hopefully see how that goes. I'm gonna take off these headphones real quick. It's a little bit harder for me to talk and stuff because it like muffles my hearing and everything, but so I won't be able to hear any sounds if any of you subscribe or anything, so keep that in mind. But anyways, yeah, so this will be one of the easier bugs to fix because it's pretty straightforward. But first, I want to go over the new technique that I'm using because I did some pretty big refactoring to accomplish like being able to do all this pretty easily. And I'm happy with how the code is working so far. So this is also all in preparation for upgrading to the new OpenGL techniques too. This will all be very helpful when we go to do that. But basically, if we look into, get out of here first of all. We go into the chunk manager.h. There is no longer any such thing as a chunk. So there are no chunks anymore, there are just subchunks, and the subchunks are either there or they're not. How's it going, Flare YouTube? Hope you're doing all right. So basically, a chunk is just sort of like a concept, and I have this make this internal because it shouldn't be here really. But we really do just work on subchunks when it comes to like rendering and everything, and render like vertex generation and all that stuff. And then the chunks are basically just there to hold the block data. So if we actually look in here, well, I'm not actually serializing any data yet, so we won't see it, but that's basically for like serialization and stuff, just so that we can load in big chunks of the world at a single time. And I'm doing all right, Flare YouTube, thanks for asking. So basically the chunk manager is basically like the thing that controls everything now. And if we actually go into chunkmanager.cpp, it's becoming quite a large file as well. But we've basically got these commands now. And so this is sort of how I've delineated doing different work. And this is actually working quite well. It makes it really easy to conceptualize how multiple threads work and everything. And so basically you can submit a command to our thread pool, and our thread pool has multiple threads. This will queue up the command with its priority depending on whether you're filling block data, which is basically just loading in the data, or whether you're tessellating vertices, which is basically generating the vertex. This has higher priority than this because we need to have the block data in order to be able to tessellate vertices for surrounding chunks. And the priority queue is super useful for this because it means that we can do this stuff. And these fill chunk commands, so I have this compare chunk command, and basically you can see that I have like tessellation is lower priority than loading block data. We'll be messing around with this too, because right now when I load this, actually I'm going to do this in debug mode as well, because this will really highlight like how laggy it is right now. And that's one of the things that when we upgrade OpenGL, it'll sort of fix. But if we just do this, and the world name doesn't really matter too much right now, we'll fix that as well too. But yeah, so you can see that this is much slower now. And the chunks are kind of loading in random order, which isn't really nice. You want chunks that are closer to the player to render in first, right? And so we'll be modifying our priority queue to take advantage of that, where basically if a chunk is closer to the player, it has higher priority. And that'll be really cool to see how simple it is to change something like that, where right now it's loading in random order, but we can easily change that to load in the correct order just by changing our priority queue. So basically we've got all these chunk commands, and I'm actually going to draw this out too real quick just to explain it a little bit better. So let's go to the drawing screen very quickly. Okay, so yeah, this actually shows it pretty clearly. So basically, instead of all this stuff, which we were sort of experimenting with a few weeks ago when we started doing all the chunk loading and stuff, what we end up having is we get a bunch of commands, right? And so it'll be like fill 0, fill 1, fill 2. And so then this all goes into the queue. And so say our queue has all these commands, and I'm spelling queue horribly wrong. But yeah, sort of like this in an array. What ends up happening is it looks for the highest priority one, and it completes that command first. Then if it has like a tessellate command in there, then it'll tessellate whichever one has the highest priority. And so basically each thread just looks in here, says, give me the highest priority thing, and I'll start working on that. The thread grabs that, starts working on it, and then that's basically taken off the queue. Then the next thread comes along, grabs the next thing, and so on and so forth. So this is much easier to handle conceptually for multiple threads. It's like a job-based system instead of what I was doing before, which was like having an array and then segmenting that array and then like having each thread work on specific portions, which was horrible design. So it did not work good. But in order to get this functionality with like a job-based system, I had to make some other changes too, which I'll talk about as well. So, and the progress of the game is going pretty good. I'll show some more stuff again for those of you who are joining a little bit later. But basically what I had to do in order to get this to work properly was change up the way that I kind of conceptualize memory and everything as well. So you'll see that the chunk command has this thing called a pool, and this is the subchunks, right? And so this is basically like a memory grabber. I don't know, not a memory grabber, but it gives you memory when needed. So basically we kind of have a giant pool of memory, and then if any chunk says I need more memory for my vertex data, it just grabs it, and this will give it some pre-allocated memory of a fixed size to do that. This is good because it means that we can calculate exactly how much RAM we're going to be using for different chunk radiuses. So you can see here that if we go up to 32 chunk radius, we'll be using around 4.2 gigabytes of RAM. Right now, that's a bit higher in the actual game because we're duplicating this data right now, which we will fix in a little bit. But this is also good because what we're going to switch to is not having the RAM on the CPU, but we're going to be using persistent map buffers on the GPU. And we'll be able to basically just have this hand us memory on the GPU directly. And then we can write directly to the GPU. You're not really writing directly to the GPU, but the way that OpenGL has made it, it makes it seem like you are. So basically we can sort of remove this work even more, and we don't even have to buffer that data to the GPU and everything. It just kind of goes directly into it, which is really cool. Here, give me 1 second. And Flare YouTube, you're learning Unreal Engine 4, and you have moderate knowledge. That's good. I did my own advanced first-person character. Cool. Yeah, Unreal Engine is like pretty epic in the stuff you can do in there. No pun intended. But anyways, so we've got this pool, and this basically gives us data on demand when needed. And so then this chunk manager is where we have all our threads. So we basically just launch a number of threads depending on how many threads you have available on your CPU. This will do one less just so that we don't like take as many threads as your CPU has completely, so that ideally these all go on separate cores. And then your main core is just free to do whatever other logic it needs to do. And then we might change this in the future too if we put physics onto a separate thread and technically rendering is on a separate thread, which is what we're doing here anyways. But yeah, we'll fix that and stuff. And maybe 2 is better because Windows is not so good. If you're talking about Unreal Engine, that might be true. I'm not sure. But okay, so anyways, we've got this chunk worker. We launch a bunch of threads, and they all basically have access to this class, right? When we free everything, we basically just stop all the threads, and we notify them that we're done doing work. So that's good. But this is sort of the main thread loop. And so basically what it does is we check and see if we have any commands, right? Those commands that I just talked about. If we have any commands, then we basically, or if we don't, we wait. So we basically tell the thread to wait until we're ready to do some work, which means a new command has been queued. If it has, we go ahead and we see if the command is valid. So we basically get the highest priority command, which is this top function, basically gets us highest priority in a priority queue. And then we pop it off the top of the stack or the queue, and then we process that command. So then, depending on what the command type is, we do different things. So filling block data is just generating like the IDs of different blocks. So this is like doing the actual terrain generation, that type of stuff. And so we check and see if it exists. If it does, we deserialize it, and this is wrong. So let me put to do in here. To do, fix this. This should be world save path. I don't want to do that right now because that might break some other stuff. So we'll wait on that. But yeah, and then once we finish generating the block data, this actually goes ahead and queues up another command, which is to tessellate the vertices. This is good because it basically says, hey, we've generated the block data. Now you can go ahead and generate or tessellate the chunks. And so then if we're tessellating the chunks, we basically just say, okay, generate the render data. And this is where all the magic happens, I guess, technically in here too. So this one is just our terrain generation function. Basically just sets all those appropriately. And then this one is our tessellation function. So this is what tessellates the chunks. So we had this before. It's basically just seeing which vertices we can add and stuff, right? This should look familiar if you've been following the stream for a little bit. And, oh, happy early birthday, Flare YouTube. Almost there. Yeah. So anyways, this should all look pretty familiar. The one thing that's changed though is this whole subchunk. Okay, so we basically get a pool of subchunks, and this is thread safe so that we can access this from multiple threads and everything. And what we basically say is right now we have no subchunk, and then we basically just start looping through. And right here, once we get a vertex, that's the only time we start asking for memory, because there's a chance that we're like inside of a chunk where nobody can see and all the blocks are occluded. So there's no point in even asking for memory for like a piece of a chunk that's completely gone. And we can illustrate this too if we go into spectator mode in the game, which you can do if you guys have your own thing. You can do this just by pressing F4, which should switch you from, so F2 locks the cursor, and then F4 will stop me from falling in physics. So you can see that I can fly and stuff very slowly. I gotta fix that too. But basically we can go underground, and you can see that we're kind of occluding all of that stuff that you wouldn't see. And so what I'm saying is, like, if we're underground and there's a sub chunk under here somewhere, which like a sub chunk could be inside, like below a chunk, because sub chunk is 16 by 16 by 16 blocks right now. If it's below the chunk, then there's a chance it's not asking for any memory at all because we can't see it. So we basically only get it if we actually find out that we're going to be drawing anything there. And so then what this get subchunk does is it basically checks and see. It checks to see if we're like asking for one on the same subchunk. Yeah, so we basically check and see if we actually need a new one, because this could just get whatever the current one is. And then if we actually need a new one, we set this one's state to say upload the vertices to the GPU. So we basically say, hey, we're done using this subchunk. Set its state to be this, and this is an atomic variable. So basically what's going to happen is the main thread will see that this subchunk is now ready to be uploaded. It'll upload it to the GPU and all that good stuff. And then if we need a new one, we basically say, hey, get us a new memory pool. And this will go ahead and look for a new free memory pool, give it to this whole processor, and then it can use this to basically generate more render data. And so then it just keeps going on and doing that. If it ever needs new data, it asks for it, and it'll get it on demand instead of preemptively getting too much data. So yeah, this works very well. And then at the end of this, we have to do a couple of state checks. So basically we see whatever chunk we were on last, if it actually had any vertices used, then we set it to upload to the GPU. And I guess this should actually be too. This is a bug. That should be, and it's less than chunk state. Wait, no, I think it's world. Max verts per subchunk -1. Okay, so, and this should be number of verts used. Okay, so basically if we didn't fill it up completely, actually, I don't know. I'm gonna leave that out for now. This basically just like says whichever one we were last operating on, uploaded to the GPU, because it's probably not uploaded already. And then we go through, and if we're retessellating things, then we would need to check and see if there are any chunks that are still needing to be, okay, well, let me rephrase this a little bit. So when we retessellate chunks or subchunks, I guess, what ends up happening is I actually just generate a whole new chunk data so that we don't like stop drawing whatever subchunk is there already. And then once that finishes, we turn off the data that was drawing the old part of the chunk, and then we turn on the new one. So that means is if we run this real quick. So if we go into here and we click create world again. So basically, like when we're adding and subtracting blocks from here, what ends up happening, that is a physics bug as well that we need to fix. But what ends up happening is like if I hit this block and I break it, a couple things happened there. What happened was we generated a whole new chunk that had it where this was no longer a block, like there's nothing there. And the old one was still there for like a fraction of a second. But then as soon as it was done generating the new data, it basically just deleted the old one and then replaced it with this new one. And then the same thing when we're adding a new block. It generates a whole new thing. Once it finishes generating, it does that. But it all happens so fast that you don't even see it. But you will notice it if I turn off the chunk preemptively, which I did notice, and I was like, okay, I have to change the way I'm doing this. So basically, that is what's going on right here, is it's checking to see if there are any old ones that we were retessellating, and if we did retessellate them, then we turn them off and we free that pool so that somebody else can use it if they want to. So yeah, it's pretty complicated, but it's actually a lot simpler conceptually than the old method that I had, and it works very well. So I'm really happy with it. Yeah, and then when we render, we basically just loop through all of the subchunks. We check and see if it's not unloaded. If it's not unloaded, like the state of that subchunk, then we basically check and see if we need to upload it. Or if we're tessellating the vertices. If we're tessellating vertices, then we say we're not using that anymore. And then we unload it. Otherwise, right here, yeah, this is where we check. So we check and see if we're uploading to the GPU. If we do, we buffer the data. We mark it as loaded. And then this is just some debug info. And then right here, yeah, we basically just check and see if we're retessellating vertices or if we're uploading. And if we are, we draw it. So this is where the draw calls are happening. And this is where the big bad part is happening that we're going to have to upgrade today. So this leads me to the part that we're doing today. if we look at this, and I might fix this first of all, because I really don't like this. What this does is it's creating a bunch of folders here. You can see M, my world, some world, delete those, ASF, ASF. We're gonna make it so that that actually all generates in a specified folder. I don't want that to be cluttering up my main folder. Okay, but anyways, if we go ahead and create this world real quickly. I'm gonna pull up the debug information. And then if you look up here, I added in this extra information. So max vert count is the maximum vertex count of a subchunk out of the last 100 subchunks. Now a subchunk can only have 1500 vertices at the moment, and then it requests more data as needed. So this isn't entirely accurate, but the minimum vertex count. So this is the interesting thing. We don't want to make our bucket sizes of our pools too small or too big, because some chunks only need 6 vertices, which is insane. It means that basically it's rendering like one face of one block. And so we could potentially waste a lot of memory if we're not careful with the size of these vertex buckets. But then if we look at the average vertex count, this is the average count of the last 100 chunks. And if I start walking around, you'll see that change as it's loading in new chunks, because that is a dynamic count. Yeah, and you can see that that was one of the bugs. So basically, this is one of the big problems with the debug mode right now. So if we switch to release, that shouldn't happen. But basically, if you hit a lag spike, then you'll clip through the physics. And then next thing you know, you'll be teleported out because you had to divide by 0. So that was one of the bugs that some people were telling me about in the Discord and everything. We will be fixing that today. If you're running on your own, just switch it to release mode up there. I'll have that set by default from now on, because you should not run into that issue if you're on release mode. It runs much smoother, but we'll be making this even better too. So yeah, you'll see that that average vert count changes as we load in more data, kind of changing things up. The reason it lags so much too when we're on debug mode is because you'll notice over here there's nothing logging, because I kind of cull all those messages on release mode, and this thing takes up a crap ton of CPU time, which is insane. Like, it'll slow down your whole game if you're logging stuff. Not cool. You don't want that happening. But yeah, the thing we're gonna be focusing on though, look at this. We have draw calls 2500. That's not that bad, but if we go to world.h and we set our radius to 32, this is gonna be bad. It's gonna start going up quite a lot, and it's gonna lag. And we want to fix this, because this is not good. We don't want a laggy game at 32 chunk radius. We want to run buttery smooth and 60 FPS all the time. So remind me, I gotta fix this first though, just where it's saving the information, because I don't want to save it in the main thing. Okay, this is interesting too, because you'll actually notice that this will take a while on release mode. Yeah, and you can see that they're kind of generating in randomly, so we can fix that with the priority queue and everything too. But yeah, so this is 32 chunk radius. Look at how many draw calls we have up there in the top left. That looks like 18,000. Yeah, so 18,000 draw calls. It's not good. If you notice, like if I start moving around, you can see that it's kind of laggy. Look at the FPS too. We kind of dip down to 30 FPS quite a bit, and it's bouncing all over the place just because it's trying to draw all this. This is a GPU bottleneck. This is not a, well, it's not a GPU bottleneck, it's a CPU bottleneck. What's happening is inside of our world, or our chunk manager, sorry. Let's see. Oh, that's right there. So inside of our chunk manager, when we're drawing everything right here, every time we hit this GL draw arrays and this bind vertex array, this is not good. This is essentially like a synchronization point for the GPU. And so every time we hit this, and it's also like overhead for the CPU, because the CPU has to communicate with the GPU every time we hit this. And that incurs an overhead, because it's like, oh, I gotta set this up, and then the GPU has to synchronize. And if you have too many of these, it slows your game down artificially, because the GPU can actually handle way more work. Like if we run this one more time and I pull up task manager, we can actually see some interesting stuff. So if we go into here, and I'm gonna move this over to performance, we've got GPU here and we got CPU here. So if we hit this, you'll notice the CPU will spike as we're creating the world. So you see that go up to 100% because we're using all of our threads. They are all working hard to generate that data so that we can render things. And then you'll notice the GPU is starting to go up there. But notice the GPU is like at a steady 38%, 36%. The GPU is not working. Okay, and then if we look at the CPU, when I start moving around like this, notice the CPU kind of spikes. That's partially because of the chunk generation, but it's also because of its overhead of calling the GPU so many times. So we can notice two things here. One, we're not using our GPU to its fullest potential, which is not good. Two, we're using the CPU more than we probably should. And that's all because of this one call. So we can actually mitigate this by using some more advanced techniques, which we'll take a look at today. And let me catch up on the chat. SC Woods, how's it going? Oh, I just noticed that you had popped in earlier. Sorry. Just one more stream, then it's all finished. I wish, yeah. Which version of OpenGL am I using? Well, we are going to be upgrading to 4.6. I'm using 3.3 right now. Yeah. And we need some more functionality that came in 4.3. But I'm just going to go to 4.6 because I want to use any of the newest features if we can, like Spurvy and stuff eventually. But yeah. And Joe Mega, how's it going? CGO Clan. Yeah, it does also show the CPU usage in Visual Studio, but it didn't show the GPU usage. And I kind of wanted to highlight that as well. Okay. So, how can we get rid of this though? And the answer to that is by using this, GL multi-draws arrays indirect. It sounds scary, but it's really not that bad. So it has a bunch of different stuff, and what this essentially allows us to do is basically generate our draw calls on multiple threads. So we can use our CPU to its fullest potential, generate all of our data on multiple threads, and then we can make one single call, which is GL multi-draw arrays indirect, which basically draws everything in one draw call. It's sort of different. There is actually multiple draw calls potentially going on. I think if we look at OpenGL versions, we can see sort of how you can get that information if you want to. Yeah, so in 4.5, there is something in here. Let's see. Maybe it's in 4.6. Oh yeah, here we go. Statistics from, so we got these statistics. Vertex shaders can get the draw ID and base vertex from rendering. Okay, so that's, oh yeah, so multi-draw indirect rendering commands that can fetch the number of draws from a buffer. Yeah, so I believe this means that we can basically find out how many draw calls OpenGL is actually doing whenever we call multi-draws indirect, because this sort of, as its name implies, indirects the way that we're drawing things, and so we don't have very good information about what the GPU is doing under the hood. Joe Mega finally finished Far Cry 6. Nice. Took you about a week. Far Cry 6 looks interesting, and I just watched Breaking Bad, and I'm watching Better Call Saul right now, like the series. And so I was introduced to that character, Gustavo Fring, who's like, I think the drug lord or something in Far Cry 6. I'm not quite sure, but very good series. So when I saw the Far Cry 6 come out, I was like, oh, that looks cool. Yeah. And you don't even have money to buy Far Cry 6. You have 3, which was free a month ago. Yeah, I usually just get the free games too because I don't have time to play as much as I would like. But yeah. Anyways, how does this GL multi-draw arrays indirect thing work though? Because it is pretty complicated, and there's not a lot of good information online about it. You can check out this thing, which is actually very good. Gives a good overview of how all the stuff works, but it doesn't really, and they give some links to GitHub resources that can give you like ideas of how to use it and stuff. I'm reading the OpenGL Super Bible, which was very good in like highlighting all the different things. So I highly recommend that if you want. It goes into a great amount of detail about how these things work, which helps tremendously. So yeah. And with your 3090, it was just able to run it at 4K and RT at 60 FPS. Dang. So yeah, but how does this work? Well, it basically works by taking in this indirect pointer. And what is this indirect pointer? It's a pointer to a bunch of these structures. So we basically have... So So it says it behaves similarly to this. So I guess actually the best place to start looking is this GL draw raise base instance. And then you can see this behaves identically to GL draw raise. And what is GL draw raise? Well, that's what we're using right now, right? So we're using draw raise. What we need to do is go up to this version, sort of, which goes up to this version, which is the one we really want. So let's take a look at this real quickly. What is GL draw raise instant-based instance? Draw multiple instances of a range of elements with offset applied to instance attributes. So it sounds kind of complicated too, but basically what this does is it allows you to draw multiple types of instances. So if you've heard of instanced rendering, that allows you to draw tons of objects with just one set of vertex attributes. Well, not vertex attributes, with one set of vertices. And then you can kind of duplicate that on the GPU instead of doing that work on the CPU. And this allows you to do multiple types of instances in one draw call instead of, yeah, I believe this allows you to do multiple types of instances. Possibly, I might be wrong on that. In fact, I am wrong on that. This is just the instances. And then this one is the one that allows you to draw multiple types of instances, which is why we're going with this one. But yeah. SE Woods, Breaking Bad is insanely good. Yes. Better Call Saul surprised me as its spinoff, but was very, very good. Yeah. El Camino was also really good too. I was disappointed that they didn't take it farther because I think Jesse Pinkwood in that whole series was like my favorite character. But yeah. I liked Walter in the beginning too, but then I like really hated him at the end. So yeah. Okay. Anyways. So yeah, this GL draw raise based instance, I've never used this before, so we're going to be kind of exploring today. But basically it works similarly to GL draw raise, as it says here, except that instance count instances of the range of elements are executed and the value of the internal counter instance ID advances for each iteration. Okay, yeah, so they say it has the same effect as for integer I equals 0. Okay, yeah. Okay, so this gives you like kind of a good idea of how this works, right? So basically we're just doing a bunch of GL draw raise command in a loop, except this allows you to do it all at once. And it would basically be as if you were going up to instance count and drawing that same set of vertex data. And then specific vertex attributes may be classified as instance through the use of GL vertex attribute divisor. Instance vertex attributes apply per instance vertex data to the vertex shader. The index of the vertex fetched from the enabled attribute is calculated as this. Note that base instance does not affect the shader visible value of GL instance ID. Okay, yeah. So basically this GL vertex attribute divisor is so that you can set different vertex attributes per instance, which I don't think we really need. But also you'll notice down here that this is only supported from GL 4.2 on. This one is only supported from GL 4.3 on. So we will be using 4.6, maybe 4.5. I don't know, because they're not going up to 4.6 for some reason down here. But yeah, so we'll be having to upgrade that. But basically this will just draw a bunch of instances. And then finally, we can look at how this one works. Basically what this ends up doing is we have some memory on the CPU that contains a bunch of these draw commands. And you'll notice that this draw command, they've typed out in like C, is this command, right? We have mode first count instance count base instance. This says count instance count first base instance. So we've gotten rid of mode, but it basically contains all of these parameters. And so this essentially allows us to draw multiple things at once, is all that's basically going on there. Yeah, send multiple draw commands like that at once. So yeah, that's what we're gonna be doing. Everyone, primitive topology, OpenGL mode. That's good to know, because I'll probably be trying out other rendering APIs eventually, so. Okay. So I guess the best place to start with all this is just upgrading this to use OpenGL 4.6. So the first thing I'm gonna do, I'm trying to think of what we gotta upgrade. So basically if we look in vendor, wait, no, first I'm gonna fix that real quickly. Windows, get special app folder. Wait, no, that's Win32 C++. Is this the one I'm looking for? I don't think this is the one. Let me just, I'm gonna steal my own code because I always hate trying to figure out how to do this stuff again. Okay, so basically what I'm gonna do is fix that file path thing first because I want to save my stuff to the appropriate file path. So if I go into here, I should be able to find how I did this before. Special, yeah, okay, get special app folder. Let's copy this. Okay, I'm just making sure that this is okay. Okay, so we're gonna copy this real quickly. I think I have a file.h in here. Nope, that's the wrong file.h. This is the one I'm looking for. Okay, so this is gonna be const char star. Get special app folder, maybe. I'm gonna do a std string for now. And this will take in no parameters. And then let's go into file.cpp, which I'm just gonna open up over here. So, trying to think of where I have this core. Yeah, okay. So we'll go into here, add this right here as well. I'm just gonna do that. Whoops, I lost my copy paste thing. Let's copy that. Paste it. Copy that, paste it here, and we're good. Okay, so basically all this is doing is it's getting, if we look into C and you go %app data, yeah, we have this .minecraft folder, right? Well, not only that, but this is where it's going to be putting our stuff, because this get special app folder basically just gets us that folder, and then I'll have to re-implement that for different operating systems and stuff too. But for now, it's fine. That way we can save our data in that %app data instead of saving it inside of our binaries executing path and stuff. So this is typically what you want to do. If you're ever saving like game state, you never really want to save that where your application's executing from, because then it just clutters up your paths and everything. You really want to have that in like a separate folder. It also means that it's easier for other people to access it too if they ever need to. CGO Clan, how many times will I be streaming this week? Just today. Next week I'll be streaming that day and all of these days, hopefully. Possibly just the 25th, 27th, and 29th. So yeah. But yeah, you can look forward to that. And Jomega also, wouldn't it be nice if SSE had a way to multiply 32-bit integers? I'll take a look at that real quickly. Yep. See, this is why I'm not doing this stuff, because it takes a lot of time to do that, I'm assuming. And I'd rather just get results real quickly. Okay, so let's go ahead and we're going to allocate memory. And then we can free that memory after we put it into a std string. So what I'm actually gonna do too is I'm gonna say static std string special app folder equals that. And we'll say if special app folder equals that, and then we're gonna do this, sh get known folder path. We need to include that. Let me see what includes I had in here. Yeah, I think we need schlob j, all that stuff. This is why I hate Win32 as well, because it's a mess. There's no consistent naming, all that good stuff, you know what I mean? Okay, anyway, so we get the known folder path of roaming app data. So that's, you know, how you know it's this folder. Whoops. There's a few other things you can put in there too to get like special known folder names. But yeah, so app data, we're going here. That's what this is doing, roaming app data. And technically, yeah, since this is in the roaming folder under app data, that's what that's getting. And then if we look at the other things, these are just some flags, the handle token, PSD path. So this is where it's basically going to put our information into. So then what we do is right here, I think that's actually gmemory allocate. We allocate size of char times, and I don't believe we need to allocate that memory. We can just do this. Temp, and then we're going to do max folder path or something like that. Max path. Maybe it's just max path. Yeah, okay. So this is 260, so this is Windows predefined thing. This is the maximum a path length can be. Interesting side note, if you've ever tried to create a folder that's longer than that, Windows will give you an error. So if we go into like this, and if I create a folder and then I just paste a crap ton of characters into here, what we'll see is that it probably won't create this. It might let you create this and then it does some special stuff. But yeah, let's, oh yeah, okay. So I can't actually type anything else. So this is the maximum path allowed. If your path exceeds this, then Windows just doesn't create it. And actually, wait, let me do that again. Okay, so if we do this, and then we try to create a folder inside of here, I'm pretty sure we'll get like an error. Okay, yep, so we can still create new stuff. Yeah, and then you'll see it stop there. So if we create this, and then if I go and create a new folder, there we go. We get this thing, destination path too long. The file names would be too long for this destination folder. What's happening here is basically Windows implicitly just has this maximum path, which is 260 characters. And if you exceed that, then you can't create that path. So, interesting side notes. Yep. You actually can. There's an option that allows it. Okay, so yeah, you can like, oh, and you can increase length. Okay, everyone's telling me. Yep. And pointer wide string uses a wchar t star, not a char star. Yeah. Yeah. I hate doing like, let's put to do in here. I'll fix that later. Pointer wide string uses wchar t star, you said? Yeah, wchar t star, not char t star. Fix this. I'll do that later. For now, I'm just not going to worry about it. And there's a group policy that you can enable. Okay, everybody's telling me, yep. By changing registry key length, Python actually asks if you want to do that during installation. Oh, cool. I did not know that. But yeah, so I guess you can. I'm assuming it will update this hash define, maybe, or you can probably just query for whatever this is automatically. We're just going to assume that max path. I'll put a to do in here too. To do, query the registry for maximum path length. And we can get that at some other time. I don't really care about that too much though. Compiler error online. My program is 60 lines. Okay. So yeah, anyways, if we go here, and I'm guessing if you go past that length that you set in the registry, it'll still give you that error that I just saw in Explorer, where it's basically like you have too long of a path. I'm guessing it's still the same thing, right? Okay. Anyways, though, so what do we do here? Oh yeah, I think this is converting WCST. Yeah, I think that's wide char string to MBS. What's MBS? I think that's just converting. So we're converting from a wide char pointer here to, oh yeah. So this, I don't think this really matters too much, Jomega. Yeah, the WCS2, yeah, multi-byte string. Yep. So basically we should be going in here. I think we could still potentially get an error though, because if max path allows for 260 wide characters, this will still be too small. So I might still want to look into this. But yeah, this will basically convert it for us. And then what we can do is we can say special app folder equals temp. Okay, cool. So then we basically put that into the string. Then right here, we'll just return that string. Okay, cool. So basically this will just query it the first time we hit this, and then from then on, it'll use this cached variable. Anyways, that was a big side tangent. I guess you guys are interested in Windows programming because I got a lot of response from that. So basically we have this way to get our special app folder now. So let's use that when we're creating our worlds, just so that we can save our stuff in a more reasonable place. So what I'm gonna do here now is we have world save path up here. And I'm actually just gonna remove, well, yeah, I'm gonna remove that completely because that should get set. And we'll do a assert here, glogger assert, that world save path does not equal an empty string. World save path must not be empty. Okay, so we'll do that assert just in case. But basically what we'll do here is once we figure that out, we'll say world save path equals, and I don't have any sort of path library right now. I can just use std file system join. Do we have a file system path join? I think we have something. Let's see. Google. to the rescue. Stood file system path join. I really hate stood file systems. Okay, it's path append. I really hate their file system thing that the standard implemented. Like, all the names are just, they make no, why did you call it append? Every other programming language calls this join. Like, there are a few other things too that just make no sense to me. And I'm like, why did they do that? But yeah, whatever, it works. So we'll say path append. Okay, so source, let's see. First, last. No, I don't think this is what I want to. I mean, I guess it is what I want, but yeah. We'll do this, okay. So say path, and then we'll say file. Do I have file in here? I think I do. File, get special app folder. Okay, slash, which you can use, I guess. Stood file system, or actually, yeah, file system, path, and then we'll use world save path. Okay, so this should basically, yeah, and then what we're gonna do is we're just gonna convert that to a string because I don't want to store that as a path. So we'll do that. Okay, so that's basically just gonna combine our path. The slash operator is like a path join operator. But yeah, I believe that's what we, and then I'm gonna log that too, just in case. So glogger info, saving data at %s world save path dot c string. So that should, or I guess I should say world save folder at, we'll do that. And I'm actually gonna do special app folder slash path dot Minecraft clone. So we'll do that slash that. Okay. Let's just move that over so that we've got that visible. Okay, so we're basically going to put it inside of a folder called .minecraft clone, and then we'll do your world save path or whatever. So yeah, that should work. And CGO clan, can you make a Poggers face so you can take a screenshot and use it, please? I'm not even sure what a Poggers face is, CGO clan, sorry. Jomega, because it doesn't join two paths, it appends a path to the path it's called on. Join implies immutable, append implies mutable. Yeah, I guess that's true. I wish they had a join option at the very least. Okay, so anyways, this should put our stuff there, which means we should be good now. Let's just delete anything we have in here. Okay, so we're good here. So now if I go ahead and do this, we should be fine. Nope, we got a build error. Okay, unresolved external. Oh, okay, so I do have to implicitly declare this. We'll just do that, since that's an external. Okay, cool. So then we'll just do my world, and if I do create world, we should see if we go into roaming, we should get .minecraft clone. Where did it save it? Let's see. Okay, so we failed on creating the directory. C users gave app data roaming .minecraft clone. Oh, it's because I have to create this folder first. Okay, so let's change that up just a little bit. So first, how I want to do this. So we'll say file system path Minecraft, or I guess app data path equals. Let's. I'm debating whether I want to put this inside of our file.h, but I'm just gonna do this for now. So this is just gonna be this. So we'll do that, do that, do that, and we'll remove that. And then we'll say file create if not exists, app data path dot string dot c string. So that should create it if it doesn't exist. And then we can do this. Will just be app data path slash that, and then that will create that directory if not exist. Okay, so now we should be good. And we should see that this will create, if we go back into here and we say my world, we should get, okay, there we go. So we get .minecraft clone and then we get my world. So now all of our junk is going to be in here. It's much better than where it was before. just cluttering everything up uselessly. Okay, so with that out of the way, let's upgrade OpenGL now. I also skipped a comment of mine about sh get known path folder. Wait, what'd you say? Also, the caller needs to free the string that is returned. Oh, huh. Thank you for letting me know. I didn't see that. Let's see. When this method returns, contains the address of null turned into Unicode string. Oh yeah, you're right. The calling process is responsible for freeing this resource once it is no longer needed by calling cotask memfree. Thank you for pointing that out. I did not know that. So then I can just sort of pass in there. Okay, so let's just copy that. And let's do that. I guess it would have been a really small memory link since it would ever only run once, but it is still good to have that gone. So thank you. I lost my chat real quick. There we go. I lost file.cpp too. Let's go back into here. And if we go back down here, we should be able to call that. And then we can pass it temp dot, where is it? PSC path. I think that's just all we call, right? Cool, yeah, I think that should be good. Let me just double check the docs there. Okay, type PW string star. Okay, yeah, so PW string star, and then it says we need to free this. Yeah, so we should be good. Cool. So I believe that should fix that. Let's run it, just make sure I didn't break anything. No leak, tiny leak, yeah. And CGO Clan, I think I'm about to read a 2,000-page book about C++. Wish me luck. Good luck, man. Yeah, I feel like 2,000 pages is not enough to learn C++ because of all the stuff that there is. A lot of stuff. Okay, cool. So we don't get any errors there. We're good. Let me just add that as a commit. So I'll open that up. We're kind of stalling because it's deleting all those chunks. Oh wait, there we go, because I had that open still. Okay, so I'm just gonna add that. Let me just make sure I don't have anything else. Yep. Okay, cool. So commit that. Do as I say, not as I do. Commit small commits so that you know what you did and you can revert if you need to. What was this? This was move world saves to special app folder, and then we'll just push that. Okay, cool. So that's good. That's one thing done today. Now let's upgrade OpenGL. So now finally what this whole stream is supposed to be about. Let's go into vendor, not that vendor, Minecraft vendor. So I've got GLFW, that's fine. We've got GLAD. This is what I need to fix. Yeah, and so GLAD is automatically generated. So let's go to GLAD. Okay, close some of this junk out. Okay, yep. So let's generate this. We're going to be going for OpenGL 4.6. Now, I'm pretty sure I want core. Or do I want compatibility? I always get confused. GL, core versus compatibility. I'm pretty sure core is the one that I want. Core profile, these features aren't available anymore. Yeah, okay, yeah. So I definitely want core because this basically just removes deprecated features, which is what I want. Okay, cool. And then let's see. GL, we're gonna be using 4.6. We're not using any of GLES. Yeah, we're not gonna use any extensions either. Maybe we'll look into that some other time. But yeah, generate loader. Okay, cool. So then we should be able to just go ahead and generate that. And that should give us our files. Nice. Let's download this. And we should be good there. Let's go into here. Gonna open this up. And we'll extract this. Then we should be able to just replace these. Let's just double check. So this is include include GLAD KHR. Okay, cool, yeah. So then if I just delete that, move these guys over there. Okay, we should be able to use OpenGL 4.6 now. That just updated our headers so that we can actually include the newer functions and stuff. And CGO Clan, you need to make a stream targeting optimization. This is targeting optimization, so we are doing that right now. So, but yeah, I like the thought. We might do like something more specific about like several different things that we can try out, but this is going to be pretty good optimization, hopefully. So we've got that. Let's just run this. We shouldn't have any issues right now. Okay, yeah. Can open source glad.c, no such file or directory. Did I not get that? So vendor/glad/source/glad.c. Minecraft vendor glad /source. Okay. Yeah, wait a second. What happened? There was 2 folders there. I have no idea what just happened there. Yeah, there was include and source. What did this do? Oh wait, do I have 2 GLAD folders here? No. Yeah, there's just 1. Okay, let me delete that again. I thought I moved this here. Okay. That's empty. Oh, I moved the wrong folders. Whoops. Let me delete that again. Let's extract this again and actually do this right this time. Okay, so let me extract that. Not open with code. That's what I wanted. Okay. So this is what I meant to move over here. There we go. Now we should be good. And we'll go back up to there. Okay, let's see if that works now. It did work, but GL create vertex arrays isn't working. That's weird. Is this deprecated now? I wouldn't assume create vertex arrays would be deprecated, but okay. 4.5 is good. Should I be using OpenGL 4.5 and not 4.6 maybe? Let's do that. Because they're not listing 4.6 on that. So I'm not sure how widely supported it is. Or something, I don't know. So we'll just switch back to this core. Let's do this one more time. Download this. I'm gonna delete that. And that. Let's just reopen that real quickly. There we go. Okay, let's see if that works now. Close that out. And let's do this again. Delete those and extract this. Okay. The gaming browser, yeah, Opera is pretty good. And how many tabs do I have open right now? 2 tabs require 64 gigabytes of RAM. Yeah, no, Google Chrome is horrible. That's why I switched away from it. Like, look, I've got this many tabs open. I know this isn't like the best way you can tell, but okay, I guess it is using quite a bit of RAM. Dang, I didn't realize this used that much RAM too. 3.3 gigs, wow. Yeah, the gaming browser for Opera is actually better though, because it can let you limit your RAM usage, which is nice. Ideally, it wouldn't be using that much in the first place, but it is what it is, so. Okay, it still doesn't like this. Is it because I need to change the version of OpenGL I'm using? Actually, I think that's in window.cpp. So, no, not in here. Let's go to, I think it's in renderer.cpp then is where I initialize the render stuff. Okay, so we load GLAD. Yeah, we should be loading GLAD, and I don't see anything that we failed there. So yeah, GLAD was initialized. Oh, and then OpenGL. So we're using the wrong OpenGL version. Maybe that's what it is. Joe Mega, Chrome is using 2.5 gigabytes. Yeah. With a ton of tabs open. Huh. I've technically got more tabs open with Opera too, because I have these things as well, and they've all got a bunch of tabs too. So it's not just those tabs that are open, and that's why I like Opera too, is because I can kind of categorize all that stuff. But yeah, why am I using the wrong version of OpenGL still though? Am I missing something here? Window.cpp. It might be because I'm setting it in here. Yeah, okay, let's set this to 4.6 or 4.5. Okay, and I'm using the core profile. That's fine. Maybe that's what it was. Is it just... Yeah, okay, that's it. Okay, cool. So, important note, everybody. Make sure that when you initialize your window, it's using the same version as the version of OpenGL you're using. So maybe I should switch back to 4.6. But considering 4.6, it looks like 4.6 was just... Well, no, yeah, that's what... No, you can use SPIR-V in this too, I'm pretty sure. 4.5? Well, you can use it via an extension. This just adds it for real. Okay, we'll think about... Let's do it real quick. I'm just going to do that. Okay, GLAD, download one more time. Just so that we have the right version, because that will be good. So, GL 4.6, not 4.5. Core profile. And, yeah, let's do this one more time. Let me just go back into here one more time. And then download that. Yep, okay. This is like speedrunning downloading GLAD, I guess. If you really want to get fancy, you can automate all this too, because GLAD is just a Python library. So it makes it so much better when you use the library, because then you can just do all this automatically, which is nice. Let's delete that. Move this over. Okay, close that out. We should be good. 4.6. And now we should be good. And my coffee is cold, which is kind of sad. But I just finished it, so it doesn't matter. Okay, cool. So now we're using 4.6. That makes me a little bit happier because we're using the latest version. So now we can use all those functions that we saw. Yeah, technically with GLAD and everything, like I could have used 4.6 the way my app was, even if I was using an older version of GLAD. It just means I would have had to load all the newer functions manually, which is not fun. But it's a good practice. If you guys ever want to experiment and stuff, it's really cool doing that. SE Woods, do you also hear the music, Gabe, or is it just the stream? It's just the stream right now, because... Oh yeah, and I see I got some followers. IHIM, YM. Thank you for following. But yeah, because when I put on my headphones and stuff, it's just a little bit... Yeah, I can't hear myself talk as good, so... But I think it's good music. My brother said it was good music, so... it should be all like Nintendo music and stuff too, which is nice. Okay, so... We've got that newer version. Now we want to switch to using... this guy. Multi-draw arrays indirect. So first thing we're going to be doing is getting this guy into our app. And SE Woods, yes, it is all good. Cool, nice. Nintendo music is always a good throwback. So I need to get like a longer headphone jack so that I can wear regular earbuds, and then I can actually listen to the music and stuff. I've been meaning to do that for a while, but I just keep forgetting. Oh, also I want to mention too that I changed up the way that our GUI works, and I really like this new style that I'm using. So if we look at the main menu, you'll notice it looks pretty much the same as it did last time, except I've changed up the way the GUI works. So the GUI automatically lays out elements now, and I kind of like the way this works. So basically, we begin a window, which is really just like a container. So a window in my GUI world just means like this is the maximum size that you can use. So it just specifies a position and like sort of a layout for all the elements. And then I basically say advance the cursor. So what I'm doing here is I'm beginning a window that's like left here. So it's like this big, and it takes up this much space on the screen. And then we advance 0.5 in the Y direction, so we go down 0.5. And then I draw the title, and I tell it to center it. Then I advance it this much so that we get some padding, and then I tell it to center the next element again, which means it'll center this button. If I were to say, turn that off, then you'll notice that the play game button is not going to be centered. Yep, so we get it off center. So that basically just automatically calculates how much space it's got on the left and the right side, which is really nice because then we can just sort of tell it to lay things out. One of the things I'm going to do too is add in a number of columns. So right now it defaults it to just one column, I guess is what this should be. And basically we're going to be able to do multiple columns and stuff to allow like it to automatically lay it out into the next columns and everything. But I do like the way this is working out. We can do like same line and stuff too. So like if I do here, it's very similar to IMGUI, just some extra functionality. But if I were to do same line there, then it would just basically place the next button on the same line. Well, it should. It might not be doing it because of this call as well. Maybe. Oh wait, no, it's because I'm advancing the cursor here. Yeah, so if I don't advance the cursor, it'll actually put it on the same line as well. And then you'll see it just sort of go up there. The reason it's kind of smushing it down like this is because they're both taking up the same space. So it basically just automatically lays everything out and stuff, which is nice. But yeah, very similar to IMGUI kind of style. But yeah. What are those window values exactly, since it doesn't seem to pixel chords or NDC chords? Oh, yeah, it's just a custom projection matrix. So if I go into the camera, I've got the matrix set to 6 units in the x-axis and 3 units in the y-axis. I might change this in the future, but I kind of like having it normalized to this range just because, I don't know. I used this specifically before because I was using Box 2D for 2D stuff, and so this was sort of how I did that, but maybe it would be nice to have it like fake pixel coordinates, so like 1920 by 1080, just so that you can use that and it makes a little bit more sense intuitively. But yeah. Okay, anyways, I will be right back, guys. So, I'm gonna put the stream on the waiting screen real quickly, and then I'll be back in like 2 or 3 minutes. Just gonna take a break really quickly. Okay. All right, guys, I am back. Sorry about that. Coffee makes me have to go pee really bad. So hopefully you had some good music though. And I wish I was a professor, but not quite that level of experience. Okay, so yeah, we've got this cool GUI system. I just kind of wanted to mention that because I really like the way it's turning out so far. But yeah, that's how I'm doing like the input elements and stuff too. And I'll be possibly modifying this more in the future. So, okay. Anyways, though, let's actually get to this thing. So let's copy this structure real quickly because I want to add it into probably our renderer is where it makes the most sense to have this. So we will have this structure and we don't need to type def it because this is C++. And I'll call this, yeah, I'll just call it draw arrays indirect command. And let's leave that. And these are all gonna be uint32. Okay, cool. So now we've got this and we can actually use it. And I'm still kind of fuzzy on the details of how we're gonna use this. So we'll do some experimenting and hopefully get this working pretty quickly. So if we go back into our chunk manager, this is where all of this is gonna be happening. I'm gonna close some of this stuff out real quickly. Let's close that out. Close that out. And we should be good there. Okay, yeah. Cool. So if we go back into here, I believe I have the renderer included already. I do not, so let's include that real quickly. Okay, so we've got that, and basically what we want is like a buffer for all of our commands. And I think we might need to create that on the GPU. Because I think that's where it gets this. Let's see if there's any like, let's see. Close this out. So, specifies the address of an array structure contain the draw parameters. Okay, no, so I think this can be on the CPU side. It doesn't have to be on the GPU. So we should be good just to do something like this. So let's go, that was called draw arrays indirect command. We'll have a static buffer of these. Call it that. We have like thousands of draw calls right now, so I'll make this a pointer and we'll allocate that memory. So then when we initialize this, down here, we'll say, GPU draw commands equals, and then how many do we want? We'll have a, let's move this around a little bit too. So move that down to somewhere over here, which is where I have all my, yeah, okay, we'll move it to here. And then we'll have a static uint32 max draw commands, and down here we'll say max draw commands equals, I'll do like 5,000 for now. So we'll do that, and then we'll say size of draw arrays indirect command times max draw commands. Okay, cool. So we got that, and then we can have another variable up here just to keep track of how many we have. I could probably use a vector for this. Yeah, I'm just gonna keep it this way because I kind of want to keep them in the same place in memory. Yep. And CGO Clan, I don't know, but is there any rendering API for C? Yeah, OpenGL. So you can use OpenGL in C. That's the whole reason that they define this as this. Because basically all OpenGL is it's a bunch of function pointers which you can get in C or C++. So, okay. So we allocate that, and then let's do draw arrays. If I can spell this here, let's just copy that. Star. Okay, so we've got this, and let's make sure we free it when we free everything. So we'll say g memory free. And we'll use this thing. Okay. So now we've got that buffer. We can use it. And then we're basically going to have some way to sort of, yeah, figure out which ones. I think what we're going to do is we're going to like draw every single command. And then for the ones that are not being used, we'll just set the count to 0. That way it just doesn't do anything with that specific draw command. I'm not sure if that might be bad practice because that could potentially, I don't know what the GPU does with that, but we'll figure it out. And Omega, OpenGL, Vulkan, and actually DX12 too. Yeah, that's true too. All the rendering APIs. If you look at the DX12 headers, they're mostly C++ wrappers around C calls. Oh, cool. Ooh, and we got some good Mario Galaxy music going on. Okay, so they say the way this works is basically if we were to do all of this stuff. So basically if we were to go through draw count and then get this, let's copy this for reference. So if we go back down to our draw calls where they're actually being generated, it's like here. And so let's do a thing like that. And this will be our reference material. Okay. So basically what's happening here is we're looping through, we get the draw command that we're currently on, which is whatever this thing is. This might not be the best one to use. Okay, and then this basically calls like this, is essentially what's happening. And so maybe what I want is actually this reference. Let's do that. And then we'll move that up. Okay, so basically what this does is it sees if mode or count is valid, generates the appropriate error. I have this in the wrong place too, whoops. Okay, so let's remove that very quickly. And let's go to where this is actually rendering. Okay, yeah, this is the render function. So we got this thing. This is where the draw calls are happening. Okay, cool. So we're doing this right now. What we want to do, I think, is just draw arrays, triangles. First is going to be 0. Count is going to be the, oh, okay, cool. So this is actually pretty easy. And then count is just like how much here. My question is, where do we put this memory on the GPU? Because we have to bind something here. Let's see. We also have to make sure we use GL divisor, so that's going to be a little bit different too. So this specifies the starting index into the enabled arrays. Okay, so what we can do is we can basically use this first variable to figure out where in the array. Okay. So let's go to the drawing screen real quickly so I can sort of sketch out what my ideas are. So basically what I think we're going to do is we're going to go ahead and like allocate a big buffer on the GPU. This will be our VBO, right? So this is, well, yeah. So this will be our VBO, okay? And then right now I have that vertex pool on the CPU, but we're basically just gonna assign it pointers into this guy. So we'll just have like pointers. And what we do is we're basically gonna segment this into different segments. And this will be, the length of this will be our vertex bucket size, or our vertex pool, I guess I should call it. Okay, so we're gonna have like a bunch of these. They go on forever. We can fill these out automatically. And then if we look at that command again, or if I look at it, because I guess you guys can't see it. So basically we have this first variable, which specifies the starting index, okay? So then our first variable will be 0 here. it will be this vertex pool size times 1 vertex pool size times 2, so on and so forth. And so we can basically just change this first variable to point to the correct location in this array where our vertices are located, and then we can use it from there on normally. Okay, so I like this idea. Let's go ahead and figure out how to implement it. Okay, let me switch the screen again real quickly to this. Okay, cool. The mouse movement is super smooth. Yeah, I'm using a, what's it called? A tablet, so I'm actually drawing on the screen and everything, not using a mouse, but that's good to hear, I guess. Okay, so basically, let's go ahead and allocate that VBO, and we'll have to split it up and stuff. Right now, what I'm doing is I'm allocating a ton of small VBOs, which you can see here. Yeah, so we've got one VAO, and we have multiple VAOs here. Yeah, we generate one for each vertex pool. So instead, what we're going to do is generate one big VAO with a big VBO, and then we'll set the vertex attribute size, which the divisor, if we look at this, GL vertex attrib divisor will basically be the index divisor, specify the index of the generic attribute, specify the number of instances that will pass between updates of a generic attribute slot index. I believe we're going to be setting this to 0. Yeah, if divisor is non-zero, the attribute of once per divisor instance of the sets. An attribute is referred as instance if its attrib array divisor value is non-zero. Okay, yeah, so basically if we set that to 0, it will basically be the same exact thing, which is what we want for our vertex attributes. So let's just go ahead, we'll say GL vertex attrib divisor index 0, 0. Just to make sure that that's index 1 is 0. Okay. Set attribute divisors to 0 because we are not instancing these vertices. Okay, so let's make sure we say that. Okay, so we do that because we're not actually using instancing. CGO clan, if we have enough amount of time and if we change the project structure, can we make this in LWJGL? Yeah. It'll be a little bit weirder to do it in Java just because I'm doing some fine memory control, but when I do the tutorial series, I'm not going to be talking like in a language-oriented direction. I'm just going to be basically like telling how to do it if you were using any language. So you could use C# if you wanted to as well. And because you think LWJ and OpenGL are dead, similar apart from any language they use. You have to expand on that one a little bit more. Okay. Anyways, though, so we basically set that to 0 because we're not doing anything. We're going to be changing this up a little bit too. And I'm going to have to change the way that our vertex pool kind of works. Yeah. So we'll figure out, because I want to basically set the memory pointers in here myself. So let's go ahead and actually go to pool.hpp. First of all, let's copy this. So I'm actually using this pool in a few different places, which is why I'm not going to just modify this. But basically, we want to be able to set the memory pointers ourselves in a certain instance, which is the case we're talking about now. So this is going to be pool predefined memory. I don't know. That's probably a horrible class name, but that's what we're going to call it. So when we construct it here, which if we take a look, we will have to change the way this works a little bit as well. Or actually, I could just... Yeah, I'm going to have to change the way this works a little bit because I don't want to quite use this. Let's remove this first of all. Okay. Gotta think about this real quickly. Java, that sounds painful. Yeah. Okay, so pool predefined memory. So basically what I want to be able to do is instead of allocating the memory here, we're going to leave data as null pointer. and there's not going to be any data length. Well, I guess there will be. No, there's not going to be any data length because this is going to be kind of different. So we're going to get rid of that. Okay, so we're going to have the pools, and then instead of having a T star of data, this is just going to be an array of pointers is what I want. Because those pointers are just going to point to the memory locations where this data lives. I think that's what I want. Okay, so let me talk about what I'm doing here too real quickly. So let's go here to the drawing screen. So basically, the way I'm using this stuff right now is kind of like I mentioned before. Let me delete all this stuff real quickly. Actually, this will be okay. Okay, so we're going to have this VBO. Let's delete this stuff. So basically, the way I'm using this stuff right now is we have this vertex pool on the CPU. And it basically does the same thing that we're doing here. And it segments that memory. Except what I want to do is move this so that it's instead one big array of pointers. So then this will be pointer 0, pointer 1, pointer 2. And these pointers are the same as these. And the reason I want to do this is because we want the memory to live on the GPU, which is basically our VBO. And then we're going to get access to these by using GL persistent mapped buffer, which is going to be this VBO. And then we're basically going to figure out what these pointers are from that, which it'll give us the address of this guy, and then we'll just kind of segment it from there. So that's my plan. So basically, our pool is going to be this thing. And this will just have a bunch of predefined pointers. So that's what we're going to be doing. Okay, so let's switch back to the other stream. Okay. So that's what I'm doing right here, right now. So instead of having a T star of data, we'll actually just have a vector of T star. And this is going to be our indirect pointers. Okay, so let's go back up to the top now. And we'll call that that, call that that. Okay, so I'm just going to provide something up here too so that we can actually get errors showing up. Okay, cool. So now it's going to give us errors. So instead of data, we're going to have a indirect pointers. And we'll initialize that to an empty vector there. I can't do that. I forgot. Okay, so this is a vector of T's, stars. We'll get rid of that. That. That's bad anyways. I should fix that up here too. Yeah. Okay. So then if we do it this way, we're basically going to do indirect pointers equals stood vector T star, and then we're going to give it an initial size, which is the pool size, or no, the number of pools. I guess we could technically do that up here too. And I think that should, yeah, that's the count. So this will basically initialize it to have that many pools, which is good for us. I guess we could make that a stood array too, which would probably be better. Let's do that. Stood array, number of pools. And then we can get rid of this altogether. It's better. Okay. And then we initialize the pool size here. Just so that my naming is consistent, I'm going to do that. Nope, that still doesn't work because I have a function called that. Okay, never mind. Let's see. Okay, then we lock this. This is thread safe. So then this basically just keeps track of which pools are being used. So it's just a bit set. Basically, every time we use a pool, we just mark it as being in use or whatever. And then for the destructor, we shouldn't have to worry about anything. So I'm just gonna, because the memory is not being managed by this guy any longer. Okay. So then we'll assert that the pool index is greater than or equal to 0. This is going to return a T star. That's good. Okay. That's all fine. So instead of doing this though, what we're going to do is we're going to say return indirect pointers, pool index. Okay, and then we'll do the same thing here. Okay. Okay, and then this get new pool is going to basically be the same thing. This is where the real use of this comes in handy, because we can just sort of figure out which ones we need. There's probably a better way to do this too, but for now we'll just do indirect pointers I. And then when we free a pool, we don't actually do any memory freeing. We're just setting that bit index to that. Okay, total size. This is going to be number pools times size of T times pool size. Okay. Just so that this is just for like debug information. This doesn't actually do anything right now. Like I don't use it for anything really. Okay, anyways though, so now we've got an array of T stars, so we can basically use this. I'm going to add one more function now. This will be void set indirect pointer, int pool index, and then this will have a T star data pointer. So this, we'll use this to basically set up this array. Okay, and then what we'll do is we'll do something similar to this. And we'll go ahead and just assert that that pool index is valid. And then we can just do indirect pointers, pool index equals data pointer. Okay, so there's not going to be any way we can really tell that this is valid, but since we're going to be depending on the GPU to hand us these pointers, this is really the only way we can sort of do this. So we have this method. Let's go up here too. And then for this, I'm just going to say for int I equals 0 until I is less than, or actually I guess we could just say number of pools. And then we're going to set our indirect pointers to null pointer. That way we'll get any exceptions if these aren't set up properly. And we want to do the same thing here as well. Okay, and actually I should do that before I lock stuff, because we don't want that to be a problem. So okay, cool. So we should be good there. Now we can use this thing. So if I go back into chunk manager, this is going to be a pool predefined memory. Okay, do the same thing there. And we should be able to use this the same way. I guess this is the equivalent to doing like an interface in Java or something, except we're just sort of doing it all manually. We'll switch that up and we should be good. Yep, so we have to fix this up too. Switch that. I think I have it up here somewhere too. Yeah, switch that. Should be good now. What's this saying? Oh, I switched the wrong thing there. Switch that. Yeah, I did that right. Okay, cool. So if we scroll all the way back up, we should be good, I believe. Cool. So now we've got this thing, which is basically just predefined memory, so we can set specific memory instances. So now what we're going to do is also modify the way that the sub chunk works. So yeah, let's check that out real quickly. Actually, let me go back down here. Okay, so now if we go into here, we're gonna have to change the way this works, because this has a VAO, VBO. This isn't necessarily what we want to be keeping track of now. Instead, we'd rather keep track of, if we look here, let's see, I think it's this first. Yeah, so we want to be keeping track of first and count, which we already have count, which is here. And then we want to keep track of first, which I can just say like, uint 32 first. Let's actually just comment these out for now. And this will never change. So we're basically going to set all this up beforehand, and then we can just sort of use it afterwards. Okay, yeah. So we have this first thing. And if this doesn't make sense, guys, just please like leave a question in the chat or whatever, and I'll try and answer anything that I'm doing, like explain my thought process a little bit better. Okay, so if we go down here now, yeah, we're gonna have a bunch of errors here, which is fine, because we also want to switch up. So we've got this draw command buffer, and if we look at this, yeah, we're basically gonna be saying these count and first stuff. And then what we're gonna do is static uint32 global VAO, static uint32 global VBO. So this is where we're gonna be putting all of our stuff. We probably don't even need to keep track of this actually, but yeah. And then if we go down here now, we're gonna move this out of a loop, or actually this part at least. So we're gonna move this out of the loop, and we're gonna say, so vertex arrays, subchunks. Okay, yeah, so then we're just gonna change this. This is gonna be global VAO. And then I'm gonna change this to that. And this is gonna be global VBO. And we're gonna change this to that as well. Okay. And now this is where that's gonna change. So instead of doing size of vertex times vertex pools.size, we basically want, I guess the size of this thing. Yeah, we want the total size of this thing. So we can actually get that too. By saying, let's see. Yeah, this is wrong now too. Let me just change that to that. Oh, I changed, wait, no, yeah, that's right. Okay, sorry. This is the subchunks.size. Okay, so we'll do this to subchunks dot total size. Okay, cool. So that should get us the total size, which you can see here is that times the number of vertices per subchunk, all that stuff. Okay, cool. Let me just log that as well, just so we can see subchunks total size. We'll do that because I think that's what we want. And then we want this in gigabytes, so I'm gonna go ahead and do this divided by 1024 times 1024. And we'll do that so that we have order of operations. Okay, Joe Mega, so with SSE, to multiply two 64-bit integers, you actually need to calculate it using the 32-bit high and low of the values. Huh. That's interesting. I know if you do any stuff with cryptography, you have to do a lot of that type of things to get like big math working with like 128-bit numbers and stuff, which is interesting. Let me put a breakpoint in here and see if we can run this for now, just to see that this makes sense. Because this shouldn't be too big. I don't want to be allocating like a crap ton of memory on the GPU because that might not work properly. So let's see, I think we're gonna get a bunch of errors. Yeah. Okay, let's, for now, just to get this to compile properly. Actually, let me go back down here. Let's go ahead and uncomment these things. And we should be good. Also, it's not full multiply since 64-bit times 64-bit equals 128-bit. Yeah, so you have to do some other stuff to get that to work properly. Okay, so this is coming from here. Oh, I gotta modify this thing too. Just change that to that. And let me find where this is defined. I think that's somewhere else too up here. Oh no, okay, cool. So that should be good. And then I think that's all the same error. Okay, cool. So let's do this one more time. Hopefully we can run it. Okay, and if I just... Cool. So then we get this. Let's see what the total size is. Okay, 2 gigabytes. Is that right? Let me do this because I just want to double check that this is calculating the correct value. Let's do that and do this one more time. And 2.5 gigabytes, it went up. Okay, why did it go up? Oh wait, I think I have a 32 chunk radius, which actually that would make sense. Yeah, so I've got a 32 chunk radius, and if I just check my spreadsheet, we should be getting around 2.2 for that. So something might be going wrong there. Let's just check my variables, make sure this all makes sense. So this total size, if we look into here, returns the number of pools times size of T times the pool size. And then if we go back into here, this says, if we actually go up to here, so the pool size is the chunk capacity. Okay, so that's how many chunks we could have overall, times 16, because there's 16 subchunks per chunk. Instance, and then we do 1. Why is this 1? Sorry, I'm just trying to think of what I was doing here. I think I want this to be this now. Oh, you know what I'm doing? I think I'm doing this wrong. This should be pool. And I think this should be that. Okay, so let's... Wait. Yeah, I'm confused. Okay, so I didn't set this up in the most intuitive manner, clearly. Okay, so this vertex pool has pool sizes that are this big. We're basically not going to need this anymore, is what I'm thinking. So I should be able to just remove that and we should be fine. Let's stop debugging real quickly too. Okay, so that should be fine. Okay, and this is just handing us sub chunks. Okay, that makes sense. So basically this should be sub chunks.total size G, or I guess let's call this number total size of subchunks. So that times that should give us what we want. Total size of that, and now we should be able to use this. Okay, I think this is what we actually want, but then that's gonna be huge. Let's see. So that's the chunk capacity times 16. That looks right. Let me just see what this pulls up now. One day you gotta show that wall poster. You say it's a portal, but from this angle I see a sword. Oh yeah, that one is a Minecraft sword. So there's actually a few different ones. So there's 3 of them up there, and then the middle one is portal. But I'll hold you to that one a day, okay? Okay, so this one is wrong now. So we'll comment that out. Oh, okay, I'm missing 11024 there. That's why. Okay, cool. So then if we do 1010. Okay, so now we should get the correct. So we should get 2.2 gigabytes here. If this is all correct. Which I'm hoping it is. Okay. We get 3.662, so that's not correct. Let's see what this says. Total size. Okay, so that's 1500. Oh, so that's lower too. So if I go back into here, this should be 1500. So we should be getting 0.7. So that's the number we're looking for. So this returns what? Let's see that. Okay, subchunks. So this returned. We're in release mode, so this isn't going to give me the most accurate information. Let's switch to debug mode. Okay, let's do that one more time. Jomega could have been one of those things that shows a different image depending on the view angle. Yeah, that would be cool, but unfortunately I didn't go that advanced with it. At least we got some good music going, right? This reminds me of when Javad X9, I think in one of his things, he's compiling this giant library, and he does a time lapse of him sipping tea for like 30 minutes. My code is not nearly as big as that though, yeah, so it compiles way faster. Okay, let's see. Play game. I want to debug this, so we are still getting 3.662, but that's not correct. Okay, yeah. So this is saying that, let me see. Wait, that's 2.62 gigabytes is what I think that is. Let me do... Let's see. Maybe I'm missing, because this is the number of bytes, or at least it should be. Okay, let me think about this a little bit more. So if we go into this is going to return the number of pools times the size of T times the pool size. Oh, I think this is what it is. Yeah, okay, I think I see what we're doing wrong here. So basically what I want is actually number of pools. Which is just size. Okay, I think that's what I want. Let's see if that gives us the correct value now. And then I'm gonna have to redesign this API because it's confusing. Okay, so we get 0.092 gigabytes. Is that what I'm looking for? We're looking for 0.73, so that's still not quite right. Essie Wood, sipping tea is so chill. Yeah, have you seen those coffee shop background where you can have as background on YouTube? It's just 10-hour videos of chill background with music. I haven't seen that. You should send one over Discord or something so I can check that out. Okay, so this gives us the maximum vertices. This gives us the number of pools that we should have. Yep. Oh, because we have to multiply it. That's so now we're missing one more thing, which is times size of vertex. Okay, so that should be what we're looking for. Fingers crossed. It's 0.732. 0.732. Okay, cool. We're in business. Most of the time those vids are jazz. Yeah, jazz is nice though. Okay, cool. So this means that we will allocate 70. Let's do this too real quickly. So instead of doing this, vertex pool, this is going to be that. Okay, cool. So basically what we're going to do now is we're going to allocate 0.732 gigabytes on the GPU. And then we're going to break that up into segments. We're going to get the pointers and basically break it all up. Let's look up mapping buffers. Okay, OpenGL map buffer. Oh wait, actually I think I have something pulled up on that. Let's see. I think it's over here. Nope, over here. Nope. Nope. Let's see. I thought I had something up. Maybe I accidentally closed out of it. OpenGL. That's not what I'm looking for. Persistent mapped buffers. Yeah, this is not what I'm looking for. Maybe it was this one? Okay, this is what I had. Yeah, okay, cool. Let's read through this very quickly because I kind of want to see. So to update dynamic buffers faster, you can use this. Yeah, multi-draw indirect command buffers. This is what we're doing. Okay, so normally if a buffer object is mapped, it cannot be used in a non-mapped fashion. Rendering commands that would read or write to the map buffer will throw an error if the buffer is mapped. Yep. However, if the buffer is created with the immutable storage and the GL map persistent bit flag, then the buffer can remain mapped while the GPU is using it. Yes, and this is what we want. So basically we're going to persistently map just one big block of immutable storage and then sort of break it up our own way. Immutable storage means you will be unable to reallocate that storage. So orphaning the buffer won't work, that's fine. You can modify the data, but not its memory address. Yes, that's what we want. So to allocate immutable storage, you call the function GL buffer storage target size with the map persistent flags enabled. Now you can map that buffer and keep it mapped forever. So let's look at GL buffer storage one more time. This music is just, it's a good mood. Jomega, did you know that throughout history there was a moment where coffee shops were banned since instead of getting drunk, people started to talk about intellectual stuff and politics? So imagine being a king and your people are starting to get into politics, man. You can't have that, right? Because then people are going to go crazy and who knows, like switch to a democracy or something. And then the king's gone. Okay. So we want to do GL buffer storage. Named buffer storage is just a different way of doing that. We don't care. So target draw indirect buffer. Oh, you can actually do this. Oh wait, no, this is for specifying an indirect buffer command target. Okay, we don't care about that. Oh, actually we do care about this though, because we have to buffer our commands to the GPU. Huh. So we actually will have to look into that in a minute. But anyways, we're doing a vertex buffer. So I think just an array buffer is fine. Yeah, that's what we want. Buffer specifies the name of the object. Oh, is this GL name buffer? No? Yeah, this is just buffer storage. Oh, okay. So we don't care about that. Size specifies the size in bytes. Okay. Data, we're gonna do null. Okay, and then flags. Specifies the intended usage. Must be a bitwise combination. Okay, cool. So we're gonna do map persistent bit. Yeah, and I think that's all we're gonna do is just this guy. So let's copy that. Okay, so we're basically gonna get a buffer of 0.73 gigabytes with a persistent map buffer. And then if we go down, okay, so you get this as a cost because now you need to do synchronization yourself. Yes, so we need to use fences to ensure that the GPU is not using a buffer while you're writing data to it. Every time you issue draw calls, which may use the persistent map buffers, you need to place a fence using GL fence sync. Next time you want to update the buffer, you will need to call GL client wait sync to ensure that the fence has been removed and the GPU is no longer working with your buffer. Okay, so this is sort of stuff that we'll implement. And I think client wait sync can work on multiple threads, which is what we want. If you do this naively, chances are your application will spend a lot of time waiting. that's when you will use double or triple buffers. We're not going to have to worry about using double or triple buffers because of the way we're going to be doing our mapping and everything. So we should be fine with that. So there's a little program to show the use of this extension. Okay, let's see what he gives us. And also, coffee got introduced around the Renaissance in Europe. Cool. Did not know that. I'm not very well on my history, so I don't even remember what happened in the Renaissance in Europe. Okay. So... okay, so we enable the vertex attribute array. We generate the buffer. He binds the buffer here. He sets up the attribute pointers. Okay, so then create an immutable data store for the buffer. So the bit flags he uses map write bit, persistent bit, and coherent bit. So I'm going to use those same flags because I'm pretty sure we need all of those. So map write, map persistent, and coherent. So we're going to do GL map write bit and GL map coherent. I think the coherent basically just says we want it to be immutable, like it's going to be the same place, and then the write bit just says we're going to be writing to this. Okay. Then he just buffers the data. Okay, so that's fine. So yeah, this maps the buffer forever then. Okay, and then when we lock the buffer, we basically just say if gsync. Okay, that threw me off for a second because gsync means something different. Okay, so he's using this like global sync. So if the buffer is fenced, you basically delete that and then we fence it. Okay, yeah. And then this waits. Yep, so then you call draw arrays, then you fence it, and then you wait until it finishes drawing, and then you go ahead and you do it again. Okay, cool. So this is pretty good. How does he get vertex buffer data? Yeah, where's that? So G vertex buffer data. Okay, yeah, so then we can map the buffer range. This is what we want. So we buffer the storage, and then we want to get the pointers. So let's copy that. So we've buffered the data. Okay, change the order I'm doing this to. So let's do this up here. And then we're going to say set up our global immutable buffer. Okay. So this G vertex buffer data, which is what we're going to call a vertex pointer, base pointer, and we're going to map it to array buffer, the buffer size, which we've got here. Where do I do that? Oh, right here. Size of vertex times that. Is that right? No, that's not right. We should be using this now. And I guess I should change this to size t. Okay, so we're using this now. And flags, so I guess we'll just have a flags thing too. This is a GL bit field flags. And we will use these guys. So we'll say that equals that. And then right here, we'll just use these flags. And we will use them there as well. Cool. So we can now get that pointer, which is great. So this is basically what we've done. We've gotten the pointer, and now we can set it up inside of our vertex pool, which is the next bit. By the way, you should try DSA version of OpenGL. What's the DSA version of OpenGL? DSA version OpenGL. And how's it going, Myri4F? I haven't seen you before, so good to see you. Direct state access. So this is a means of modifying OpenGL objects without having to bind them to the context. This allows you to modify object state. Oh, that's cool. Huh, that's, oh, okay, so this is by like using the named frame buffer stuff and all that. Okay, yeah. I may look into that at some point. For now, I've got it like in my head about the binding and everything, so I'm just used to binding and stuff, but that will be useful to check out, which I will do in the future. Okay. So we've got this. Let's go. This is going to be through the subchunks. Size. Let me just make sure that this is all correct too. Okay, so basically this is the subchunks times the maximum verts times size of vertex. Yep, so we basically have one vertex pool per subchunk, and we're going to be setting up those pointers. And there's a tutorial from GitHub. Cool. Okay, cool. I appreciate it. I will check this out in a little bit. So now when we go through this, we're basically going to be able to say subchunks I data. This is going to be our data pointer. Is that right? Data? Yeah, I thought I called it something different. Oh, wait. Okay, I see what I'm doing. So, well, no, yeah. So basically, okay, yeah. So basically I just had the data pointer stored here, which is still good. I want that there, but we're going to be removing this now. So we'll set the pointer this way, like each subchunk knows where to write to, or vertex pool, I guess. But then we want this first command, which is basically going to be the same thing as this data pointer. Okay, so we'll go through here. This is not going to be vertex pools I now. This is going to be our base pointer plus, and I think we can just do I times world max verts per chunk. Okay, cool. So basically this base pointer is a vertex pointer, which points to something that contains this many vertices, which is this size times that times that. Okay, yeah, so this should all work. So basically we're just going to go through and segment the data that the GPU gave us, so that we can get specific pointers to each one. And then we can also say subchunks I first equals base pointer, or I times that. So I guess it makes more sense to do that, and then we can say plus chunks I first, which if we look at the documentation one more time, is essentially what they do here, right? Yep. Well, I mean, I guess it's not what they do here, but yeah, okay, so that should be good. Cool. So we're setting all that up appropriately. We set the state and all that stuff, so that's good. Cool. So now we have a mapped buffer from the GPU, and we have the data pointers, so we should be able to write like directly into the GPU and everything. So let's just go with this. I'm not even gonna do any fencing yet, which is probably bad, and we're gonna break stuff. But I want to just go with this for now, just to see if we can get this to work as is. So we're gonna have to change some stuff probably where we draw now. Okay, yeah, so right here, we are going to be filling out our command buffers. Okay, I'm trying to think of how this is gonna work. So we need one more buffer now, and this buffer is gonna be our buffer of commands, which we've got here, somewhere up here. Oh wait, it's down here actually, sorry. Yeah, so we got this draw, raise, indirect command buffer. We want to upload this to the GPU as well, I believe. So this indirect specifies the address of an array of structures containing the draw parameters. Does this address have to be like a buffer on the GPU, or can it be like CPU? I guess that's like kind of where I am a little bit lost on this. I think that can be on the CPU. So we're just going to use the CPU address for now, see if that works. And then if it doesn't, then we'll modify in the future. But yeah, that should be fine. So basically we're just going to do GL multi-draw, raise, indirect. This will be the command buffer, draw count, stride. So scroll back down here now. Okay. So let's go ahead. I'm trying to think of how I want to do this. Let's go into here. I'm going to add one more field to the subchunk, which is uint32 draw command index. So each subchunk is going to relate to a specific draw command, and we'll kind of use that. So then right here, when we're setting all this up, we'll say subchunks I draw command index equals I. And that way we can index directly into our draw command buffer, which is this, which if we look is the size of max draw commands, which I guess instead of doing max draw commands, we should just make our draw command buffer as big as our subchunks. We might change, I'm probably gonna change this in the future, but for now what I'm gonna do is just say, yeah, let's do that again. To relate to our subchunks. Okay, so instead of doing this, we're actually gonna do subchunks.size. So we'll have enough draw commands for each subchunk. Comment that out. Comment that out up here too for now. Okay, and then for each of these, then we basically set it to that index. Okay, cool, so that's good. So then when we're over here, okay, so when we're over here, what we can do instead is just say subchunks I, or actually I guess draw command index equals subchunks I. Oh, I'm in the wrong area again. Okay, I should be down here. Right here. I draw command index. Okay, so now we can get the draw command. So then we'll say draw array command equals GPU draw command buffer I. We'll just do a reference here. Okay. Okay, so that's fine. So then instead of doing this, we don't need to bind anything. We can just say draw command dot base instance, which if we look in here, what does base instance do? I think we don't need that. So base instance specifies the base instance for use in fetching instanced vertex attributes. I think we can just set that to 0 and that to be 1, and that should be the, yeah, okay, so GL draw arrays instance base instance is identical to GL draw arrays, except that instance count instances, yeah. So specific vertex attributes may blah, blah, blah. So if we just set that to 1 and then base instance to 0, I believe we should be fine. Yeah, so that's what we're gonna do. So we're gonna say base instance equals 0, instance count equals 1. Okay, and then count is how many vertices per instance. Well, the count is just gonna be I number of verts used. And then first, we already have that set up. Well, actually, do we? No, draw command dot first equals that. Okay, cool. So then we should be good. And then we don't even have to do this. So let's comment that stuff out for now. Okay, so we should be good here. And then basically what we're gonna do is after we finish all that stuff, so we loop through all the subchunks after we've like set up all the draw commands, then we'll do this, except we're actually gonna call GL draw this thing. So GL multi-draw arrays indirect. So we'll say bind the vertex array, which is good. So we wanna do our vertex array that we set up there, which I think we called global VAO. Yep. And then we'll say GL draw arrays multi, what is it called? It's a big function called GL multi-draw arrays indirect. GL multi-draw arrays indirect. Okay, so we're gonna do triangles. Our indirect buffer is our command buffer, so GPU command buffer. Our draw count is how many draw calls we have. So that's just subchunks dot size. And then our stride, we're gonna set that to 0, which means we have it tightly packed. Okay, so we can comment that out now. Or just remove that. And then we just need to cast that to a void star. Okay, and I think this should just work. We're not fencing anything, so there's a potential that we could like do bad stuff. Hopefully we don't do bad stuff. Hopefully it just works and we can go from there. Okay, so VBO is not a member of this. Oh, cool. Yo Mikester is raiding. Cool, thanks Mike. So that's my brother, and I guess he's raiding us now. Zumi-kun is now following. Thanks. How's it going, guys? I hope you guys are all doing all right. Uh-oh. Looks like we're gonna get a bunch of new viewers. Hopefully you guys will enjoy this, because I hardly understand it, so it might not be that enjoyable. Okay, so we're almost there, though. So basically, if we bind this buffer... So this is when we're uploading the vertices to the GPU. We don't even actually have to do this anymore. So I should be able to just do this. And I think it should just work. And Nebular, you do coding in uni as well. Cool. So if you guys code, then you might actually enjoy this stuff. Okay, let's see if this works out. We should get the world. Yeah, and then we're going to get an error here, which is... Dang, you guys are all following too. Thanks for following, everyone. And you have not a clue of what's happening. It's all good. Don't worry. Okay. So, thank you everybody for following. I would say all your names, but there has been a lot of you, so that's a lot. But thank you. Man's just chilling on Visual Studio. Yep, that's basically what I'm doing. And Kohler, you're coding a game in Unity right now. Cool. Unity is pretty awesome. It makes doing that type of stuff way better. So yeah. But we got, I think we got an exception here. Oh, because I don't think I actually set these up. Oh, I forgot to do one thing over here. So the last thing I want to do is say subchunks. I guess dot set indirect pointer here. Oh, okay. So actually, I think... Oh, okay. Actually, I think I should probably change this because we don't actually need that, which is good. So if you guys are just joining, what I'm doing is I'm basically using this thing called OpenGL, and I am using the newer techniques in it and stuff that allow you to speed up your game. So that's basically what I'm doing. And so right now we're just speeding up our rendering techniques by doing a bunch of different stuff. Let me just go ahead. Gotta fix all this stuff real quickly too. Okay, so that should be good. And I should be able to change that. And I'm gonna have a couple more errors, and then I should be good. Yep, so this is gonna be a couple more errors. This should be this. And that as well. Okay, and I think I should be good. So we'll see if this actually works or not. I have no idea what's gonna happen. Okay, so we got some more errors. Let's see. So command.subchunks. This is not... Oh, I gotta fix this as well. Okay. And thank you for following again. Hack Engineer, thank you. So, it's not coding if you don't get a million errors. That is true. But hopefully that was a million errors just because of that one thing. Yeah, okay, cool. Okay, so now if we go... So this is basically queuing all the chunks and stuff. Okay, and then we're getting a bunch of errors here. Because I have not done this right. Okay. 0 is bound to draw indirect buffer. Okay, yeah, so that was something I was wondering about. So basically, for those of you who were on my stream a little bit earlier, And thanks, Mike. And yeah, I'll probably see you later today. Okay, so for those of you who were following my stream a little bit earlier, this indirect pointer, I was wondering if this had to be on the CPU or GPU. It looks like this does have to be on the GPU, which is weird because it's taking a void star. Specifies the address of an array of structures containing the draw parameters. Let me look at that example we saw earlier. Yeah, right here. And potato waffles. Oh, hey, I know that guy. Yeah. This stream will be about fixing all these errors now, basically, but we're sort of at the end of the stream, so hopefully it'll be just a few errors that I have to fix, and then it should be good. So the thing I'm looking for is in this guy's example, which if we look here, this says draw using the vertex buffer. But he's not using, oh, this is persistent map buffers. This is something else. Wait a second. So I got to go GL multi draw arrays indirect. Command. Okay. Or actually, I guess example. So I got to look for an example of this just to see how it's used. Okay, cool. This is pretty good. Okay. So sweet, we got some pseudocode. Okay, so they're just copying the documentation there. Let's scroll all the way down. Nope, they're not going to give real code. Okay, so we need some real code real quickly. Let's see this one. Okay, so okay, this is probably what we're looking for. Nope, that's not what we're looking for. Okay, this is what we're looking for. So, okay, we are drawing triangles, and then this is passing null. Okay, so it bound an indirect buffer. Okay, cool. So yeah, basically I've got to just turn that into a buffer, and then it looks like we pass in null there. So we should be able to fix this. And thank you, Grace Luther, for following. Joe Mega, the GPU needs to be able to access that memory to be able to know what to do. Yeah, that's what I was thinking too. So it looks like we'll have to set up a buffer on the GPU, and then we can basically go from there. So what I can do is, it looks like if we just, let's see. Yeah, if we change this to be null, let's just do that. I didn't know if this was like, if calling this draw call would actually upload those vertices or whatever, or I guess those draw commands. So that's what I was wondering, but it looks like it doesn't. So what we have to do is we have to go back up to here, and then we'll have this is our draw command buffer, and then we'll have a static, actually we can just change this to be draw command VBO. So then we'll go down to here. First of all, this is going to be our render VBO, and then we will go ahead and just change that and change that. Okay, so we should be good there. And then what I'm going to do is, when we're setting up the draw commands, we're going to go ahead and just copy that thing that I had just a second ago. Okay, we're going to copy this, and we're going to say GL create vertex buffer. Or I guess arrays. I think we can just do create buffers. Yeah, okay. So we're gonna do this, and then we're gonna say 1, and we're gonna give it the address of that guy. Yeah, and then we're gonna say GL bind buffers, or buffer. Okay, so then we're gonna bind, and this is gonna be a GL draw command buffer. I think it's something like that. Draw indirect buffer. That's what we want. And then the buffer is going to be that guy. Okay, and then we're going to say buffer data, and we're going to buffer a bunch of void data. So then this will be GL draw indirect buffer. Size is going to be this. And then the data is going to be null, and the usage is going to be GL dynamic draw. Actually, let's see. I'm going to see what buffer data the parameters are, because I think I've used the wrong parameters for like a long time. So let's look that up real quickly. And Jomega, let me see. If you need to know if it needs to be accessible by the GPU, just check the DX12 or Vulkan version, since they are very explicit about stuff like that. DX12 or Vulkan. Yeah. Since we're using OpenGL, it's a little bit different, but yep. Okay. So these are what we can target. Okay, so usage. We want to do... Yeah, so we're just going to do dynamic draw, which should tell it that we're going to be writing to this and stuff. Okay, so that should allocate the memory and everything. And then basically we create the VAO, we bind that. Okay, cool. So then if we go back down to here, right before we actually draw things, we'll just say GL buffer subdata. And then we'll do GL indirect draw buffers. Yeah, that guy. Offset is going to be 0. Size is going to be... Do I still have that copied? No. Subchunks dot size times draw arrays command. And then the data is going to be our GPU draw buffers, or draw command buffer. Okay, I think that should fix it. Let's see what happens. Whether it's OpenGL or Vulkan, if they still have the same memory requirements, if the driver isn't allowed to do stuff like that. Okay. Well, the thing is, like... yeah, I think I could use persistent map buffer to basically ask the GPU for some memory that I can write to, but I don't want to do it that way, so I'm just going to create the buffer and then sort of let OpenGL handle that for me. Okay, let's see what happens now. Okay, we're not getting errors. It's not drawing anything yet, but that could be fine. Okay, it says I'm getting 5 draw calls, so that's definitely wrong. And my CPU is going crazy. So something's not going quite right there. So let's stop everything real quickly. So I think what might be going wrong is something along the lines of here. So we basically say this. Okay, let me just double check that guy real quick. I'm thinking it might be because I'm not fencing my calls to writing to the GPU and stuff. Yeah, I'm just looking through this real quickly. So yeah, this is... Okay, so it looks like he's just uploading the data there, and then what is he doing here? So he's just saying... Okay, wait, let's see what this indirect buffer is, because that's probably what I need to look at. So indirect buffer... doesn't even show that, I don't think. Okay, so that indirect buffer, am I missing it somewhere up here? No, I think he's just not showing that part. That's probably the important part. Okay. I think what... Actually, wait a second. Let me go back up here. It might be up here that's the problem. Okay, so if we have this set, then we just set this to uploaded, which should be fine. And then if it's set to uploaded, I get the draw command. And then I just set up all of that stuff, which should be fine. Yeah, so it looks like what's happening is I'm never actually finishing drawing that stuff. Okay, go back down here real quick. Okay, so that's all fine. Yeah, I think that's all fine. Huh. Let me run this one more time and see what's happening. Okay, so I saw a warning up there too. I should probably check out what that warning is. Yep, so we do all that. Let me go up here and see what that warning was. Oh, that's fine. And then how many draw calls? We're still getting 5 draw calls. I think that's probably what the problem is. Let me just do like a information log here. Or I guess... up here is where I would want to do that. Okay, so inside the thread, I'm just going to log out to see what's happening. Okay, so we do this. Let's do a log here, and we'll say tessellating vertices. And then we'll just do the chunks position. So this will be chunk coordinates. And we'll do that. There. Okay, cool. So that should tell us when it starts tessellating them. I think we should be getting to this point just fine, and then I have to see if we're actually finishing that afterwards. Okay, so it queues all of them. Okay, and then it tessellates all of them, so that's good. But it never finishes tessellating them, which I think is where the problem is happening. So if we scroll back down to here now. Inside of this render. Jomega, okay, seems to be best to pass the data to GL draw indirect buffer, bind it, and then call the indirect function, or the address of the offset in the indirect buffer. Wait, let me see. Okay, seems to be best to pass the data to GL draw indirect buffer. That's what I'm doing, yep. Bind it, and then call the indirect function, where the address is the offset in the indirect buffer. Oh, okay, so that makes sense. So the address I'm setting to null, which basically just means start from the beginning, which is what we want. So that makes sense. Let's see. What I want to check though is, because it looks like we're not ever finishing this thing. So we should be getting that. And whoa, what was that? So gifted a sub to Eddie Dev. Hey, thanks, Nidal. That's pretty cool. And to Jomega, to everyone, it looks like. Dang, man. Thank you. Or to a few people, it looks like. But thanks for that, Nidal. That's pretty cool. Okay, so this should be when we finished. So let's say uploading to GPU, and then this is going to be our current subchunk here, I believe. Yeah, that really is awesome, Nidal. Thank you for doing that. And Moonman Crew, thank you for following too. Okay, so let's see if we can figure out. So current subchunk, chunk chords, that's what we want. And we'll do the same thing there. Cool. Gotta support the coders here. Yeah, thank you. I appreciate that. Let's go ahead. We're also going to do this up here. Okay, so this is when we finish tessellating vertices. So let's actually just call that finished tessellating verts. And that's not there, but should be right there. And then I'll do the same thing here as well. Okay, cool. So let's see if we actually finish tessellating the vertices, because I think that's probably where we're going wrong. And Essie Woods, you still going? Still going to expand on that a little bit more? I'm not sure what you're saying there, Essie Woods. Sorry. Okay. So we're queuing. And then it should start saying that it's finishing tessellating here. But it's not actually finishing. So this is what leads me to believe that we're not actually doing anything there. Oh, you know what it is? It's probably, yeah, it's definitely because I'm not fencing those calls. So let me do a little experiment here. So if I go up here, and if we just get rid of this call, I have a feeling this will magically fix everything. I think what's happening is the GPU is trying to access the same... Oh yeah, the stream is still going. I'm probably gonna be finished after I fix this bug. But I think what's happening here is basically the GPU is accessing the same data that the CPU is, and then I'm basically getting a synchronization problem there. So we should see that should say finish tessellating now, hopefully. Nah, it still doesn't look like it's doing it though. So that is strange. Yep, so we're definitely getting into here and it's never finishing these loops, which is really weird. Okay, let's see. We should be hitting this at least. So let me see if I'm hitting this. Okay. We should be hitting that a lot too, because the multiple threads should be writing to that. Okay, so then it should queue it, this should generate the data, and then we should start hitting that a ton. But we're not. I'm guessing this is where the problem is. So something broke. This is good though, because this means that it's a simpler problem than I thought. Okay, so what's going on there? So if we go back up to the threads, okay. So we should be getting to here at least. So right here, yeah, and we were, because I checked that. So this basically queues a command that should be tessellating vertices. So then if we get to here, tessellating. So we should hit that at least. Let's see if we're hitting that. I feel like I'm so close, like this close. And it's just this last little bug, whatever's happening here is just kind of messing everything up, which is a little bit annoying. Okay, so we're not even hitting that. Okay. Are we hitting this? I spelled queuing horribly wrong there too, and I don't care because I don't know how to spell that correctly. Queue is one of those words that's horrible to try and spell. Okay, so let's see if this works. Oh, I spelled it right there, I think. Maybe. Okay, yeah, so we're queuing those commands. And then this should stop after a while. It's still going. There's a lot of chunks, so it's going to queue a lot of commands, but I feel like it should probably have stopped by now. Something weird is happening though. So basically I say that it should do that and then that queues it. And then it should go to this point. Let me run this one more time. I gotta see what's going on here. This is weird. Jomega Q, where 80% of letters are silent. Yeah. So if I'm interested to know what Q looks like in other languages. I know some of you guys are from different countries, so is it as horrible spelling it in different languages as it is in English? Okay, let's see if this ever stops, because this should definitely stop at some point. And if it doesn't, then there's definitely a problem, because we're like constantly queuing other commands. Or it looks like we might not be removing commands. Give that just a little bit more, see if it stops. The good news is I basically cut my GPU usage in half, or my RAM usage in half. This used to be 4 gigabytes, not 2.6, which is very good, and that's what I was expecting. Okay, Vertex data was null pointer. Wait, did we finish queuing commands? Oh yeah, so we finally finished queuing commands, and then we started testing. Why is it taking so long to... And why is it queuing so many commands? This doesn't seem right. The number of commands that we get queued here should be equal to the number of chunks. So let's actually, I'm gonna do another experiment now. So let's go up to here and count how many things we're queuing, because we should get the same number. Okay, so let's see. I'm gonna get a static atomic int. Wait, I'm in the wrong place here. Wait a second, I gotta go up a little bit higher. Okay, so up here, we'll have a stud atomic. I'm gonna make this 64 bits. Number of queued commands and queued. This is going to be the number of, yeah, queued commands. I don't know. Call this number fill commands. This is the number of render commands. Okay, so these should be equal at the end. So when we do this, we're going to say number of fill commands plus plus. This is going to be number of queue. Or actually, I'm going to do that in a different place. We'll say right here, number of render commands plus plus. And then we'll say G logger. And we'll do that. And then we're going to actually do this in a different place. So we'll move this out of here. And then where we initially queue it is right here. Yeah. So then we'll just do a, well, yeah, we'll just do like int number of fill commands here equals 0. And then as we go through and upload them, yeah, this is where we queue them. So then we'll say number of fill commands plus plus. And then at the end, we'll say number of fill commands. Okay, let's see. These should be the same number. So I'm gonna be interested to see what this actually is. Oh, and I got all the languages. Cool. So nope, in Portuguese, you write it as you read it. That makes sense. And in Swedish, it's called ko. Seems the Q is also a valid word in Dutch. Huh. I probably said that really wrong to the Swedish version because I'm not even sure how to pronounce that, so. Okay. We just need to do dot load here. Okay, let's see if those are the same number. And you skipped my Dutch version. Oh wait, you wrote it in Dutch? Wait, if it's standing in a queue, it would be, is that just RJ? Or is that RIJ in Dutch? row. Oh, okay. See, that makes sense though, and those all look easier to spell at least than the English version. Okay, so this is going to tell us we gotta update that number of fill commands a little bit more because that's not quite right. Number of render commands, yeah, let's update that real quick because that's telling me the wrong information. Yeah, so we'll do a static int there. That way we get the correct number. Okay. Portuguese version is fila. I think I pronounced that right, hopefully, or close at least. But IJ is a single sound. It has the same exact same sound as L in Dutch. Huh. Okay, so we have 3,208 fill commands. We should get that for our render commands too. Actually, I guess we got 4,096 fill commands. We're up to 1,188 render commands. That makes sense. Oh, dang, this is just going really slow for some reason. Okay. I think this is probably like a locking problem on multiple threads, and that's why it's going so slow. Nope, we're up to 2,884. Okay. Okay, almost there. Very close, actually. Okay, cool. At least I got it close. And it's A, not L. Okay. Did we get the same? So we got 4,089. Okay, so we have the wrong number of render commands. Or no, that's right. Yeah, okay. So it looks like everything's going right. It's just going way slower. I'm gonna have to go real quick again, guys. So I'll be right back. And then we will continue where we left off. Okay, I am back. I want to solve this really quickly because... Yeah. Oh, wait. Okay, so we're getting vertex data was 0. Oh, I think I know what's going on, guys. So this might actually all be working properly. I think we're really close, too, and I want to get this working properly. Let's see. Okay, so when we go through up here, oh crap, okay, this is what's going on. I think. Wait, no, okay, yeah, so this data pointer, we are setting this data pointer. Let's try and write to this data pointer real quick. We should get... I'm going to do that real quickly just to see if these are valid pointers. They should never be null pointer, which is what we were getting for some reason. Trying to think if maybe there's something else, because yeah, and let's remove those logs because I don't need those anymore. I think we're fine there. It's just taking a really long time. So let's just get rid of that. And we can get rid of that. I think that's fine. Actually, we'll leave it for now. Okay, get rid of that. This should throw an exception if we are doing something wrong there. Let's run this real quick and see what happens. Drawser the Kai. Now, thank you for following. Veracing versus Veracing. The first is surprise and the latter is turning something ash. Yeah, there's no... I've tried learning some other languages in the past, but never been very good at it. So, hello, sir. How are you doing today? I'm doing all right. How are you doing? We are debugging some... Yeah, okay, cool. This is good. Debugging some stuff right now. So, let's see. Base pointer is null. Oh, okay. So something's going wrong right here. Why is OpenGL giving us a... Sorry, I'm going to drink some water real quick. Why is OpenGL giving us null there? That is weird. Okay, so we buffer data. That's the same size. Same size. We want map persistent bit, write bit, coherent bit. That's okay. And then it's giving us null pointer here. Why is it giving us null pointer here? That makes... Oh, wait, did I change this? No, yeah, GL array buffer. Let's see. Let's look up the documentation. And that's good. I'm glad you're doing all right, Drawser the Kai. Can I learn coding by yourself and make your own indie game too? You can. There are a lot of great resources on YouTube and Udemy and other sites. YouTube is free, so definitely go there if you're looking. And if you don't know any coding at all, I would suggest starting with like something like Unity, because that'll be a lot easier to start learning how to code and make a game at the same time. So yeah, Unity is also free too. So all good stuff. Okay, so buffer specifies the name. Okay, wait, target. So we got target. We can do array buffer. That's good. Specifies the name of the buffer object. Offset specifies the offset. What do we do for offset? We do 0. That's fine. Length specifies the length of the range to be mapped. Okay, so I think... Whoops. The only problem we have here, I think, is probably that this... I'm using a size here. Whereas if we look at buffer data, I'm not sure. Copy into the null if no copy. Okay, size specifies the size in bytes. Okay, that's what's going wrong here. So this is a length. This is a size in bytes. So this should not be the size. This should be that. Okay. And I think we should be good there. Okay, let's see if we get the correct stuff now. And thank you, it's really helpful. Yeah, no problem. There's lots of great resources, so definitely check those things out. And if your goal is a game, commercial engine is a good idea. Yep. Or if you want to do your own engine, a specific game that doesn't really work with an existing engine, custom engines. Yeah, that's quite advanced. Yeah, if you find you really enjoy coding too, more so than you do like just the game creation aspect, then it's always good to go with a, well, not always good, but I would say it's more fun to like go the custom engine route, because if you really enjoy coding, then you'll be doing a lot more of that than you normally would. Okay, we're still getting no pointer here. Let's see what's going on. Wrong thing. Okay, so map buffer range, map all or part of the data store of a specified buffer object into the client's address space. Offset and length indicate the range. Okay, a pointer to the beginning of the mapped range is returned once all pending operations on the buffer object has completed and may be used to modify and or query. Okay. If an error occurs, a null pointer is returned. Okay, if no error occurs, but we're not getting like, oh wait, we are. Okay, we got an error here. Whoops. Okay. Expected GL stream draw, static draw, dynamic draw, stream read, copy. Oh, this is the one we're looking for. Offset and or length are out of range. That's what's going wrong here. Okay. And we're in the jungle now, in Mario, I guess, with this music. Okay, so it looks like we're out of range here. So this is the total size, which if we look up here, right here, okay, total size is that times size of vertex. Yeah, so if we did length, we should be able to do that size times that. What's this size return? Yeah, that just returns the number of pools. Oh, do we ever buffer this? I don't think I ever buffer this. Wait a second. Yeah, okay, that would... Wait, but do I buffer it down here? Yeah, I buffer it down here. Okay. So we get the total size there. Oh, wait, am I doing that wrong? I think I have that flipped. Buffer data. Okay, size, then data. No? Yeah, that's all correct too. Unless what's happening here, enum is valid. Let's hit a breakpoint in here real quickly, because I think that might give us more information. Okay, so if we do this. Okay, we have no errors here. No errors. Okay, this is what's going on. So it doesn't like the fact that I did this with these flags. Because I think this should just be, wait, let's see. I had that example. Yeah, okay, so draw indirect buffer. I think I had a different example somewhere, which I've probably lost. Okay, wait a second. So let's look at this one more time. I think I might just have to change this to like GL dynamic draw. Let's see if that works. And then I'm gonna look up the documentation later just to make sure I'm doing this right, because... Okay, so we're good there. Okay, no, we're still not good there. Cannot map a buffer for persistent access when it was created without geomap persistent bit set. Yeah, okay, so... Okay, so this is where I'm like, how do we do this? Because it says the usage must be one of these. Oh, wait, okay, usage is a hint to GL implementation. This is what I'm looking for. Stream, the data store will be modified, static, dynamic, draw, read, copy. Let me see if I can find that example I had before for the map buffer stuff. Let's see. Yeah, let's go back to this thing because I think I'm doing this wrong. Okay, so here we go. So we generate a buffer, we bind it, we set up attribute pointers, then we buffer storage with these flags set. Oh wait, that's GL buffer storage. Am I using something different? Yeah, okay, this is, oh. Okay, so if we do that, I think we should be good. So the wrong OpenGL call. And I think with that, we're probably almost there. Okay, so we hit that. That's fine. That's fine. Okay, cool. If we continue, we get no errors. Okay, cool. Let's turn off these commands real quick. Number fill commands. Let's look for that real quick. Get rid of that. And I'm going to get rid of that up here too. Yeah. We no longer need that. Okay, so if we run this now, it should all work, hopefully. It's actually not going to draw anything yet still, though, because I need to uncomment that piece of code I had down here. Okay, yeah. So let's do that again, and now we should be good. Okay, so now it's queuing all the chunks. It's gonna fill all of them, and then it's gonna queue them all to be generated on the GPU, and then we should be good. Looks like we're just locked though. Yeah, this is... Okay. Okay, yeah, so I think what's happening now... let me comment this out again. I think I probably will have to change the way this works to get this to work properly, but let's see if this at least will run. Okay, so it looks like we're all good here. Okay, cool. So we are rendering stuff. Cool. Yeah, so it looks like I'm gonna have to do some more stuff with that. The way that we're queuing those commands and stuff. Let's see if this works though. So I should hit like tessellating chunks, like it should start logging that and everything. Your PC seems to be struggling. Sync from all the skip frames you had. Yeah. I'm gonna have to look into that. I think it's just like synchronization issues right now. So, and then also because of all that logging in the console, it really slows things down. Okay, it looks like it's tessellating everything just fine though. Except now it's like really lagging, and I think that's because of those logs. Yeah, I'm like 90% certain that's because of all the logs. Once those stop logging out, it'll probably be fine with the frame rate again. Right now we're hitting 15 frames per second. Yeah, and then once those stop, it'll go up. I'm just gonna make sure that that's true though, so we'll see. Okay, it's still going, man. There's a lot of stuff that it was doing. Oh, this is actually gonna be quite a bit more too, because this is, yeah. The good thing though is you can see the draw calls are going up. No, that's not good though, because it's going up quite a bit. It should not be going up that much, so there's something wrong going there too. Oh wait, no, okay. Actually, yeah, that is fine because we are doing 32 chunk radius, but my frames are still really low. CPU looks fine though. So I'm not sure why the frames are so low. Let's do that again real quick. Yeah. Because if you look at the thing over there, let's see the GPU usage real quick. Yeah, GPU usage is low too. So I wonder why my frames are so low now. That's really weird. Okay. I'm probably gonna have to debug this off stream, guys. Yeah, that 5 just looks wrong. Yeah. So I'm probably gonna debug this off stream, but we're basically almost there, I believe. I think what's probably happening right now is just like synchronization errors and stuff, which is why we're getting such low frames and everything, but I'll probably figure that out in just a little bit. But yeah. Thank you everyone for coming to the stream though, and thank you again, Nidal, for those gifted subs. That was really cool. And for everyone who was able to watch. Hopefully in the next stream, we'll be implementing some more interesting stuff. Probably more interesting terrain generation and everything. I'll be streaming the 22nd and then hopefully this whole week. And we'll probably be making some very good progress then. So yeah. Thanks again, guys, though. And I'll see